So what is the EPC Global Architecture Framework? The data flow from the RFID tag to the EPCIS information service can be presented by this slide. The data recorded in the RFID tag will be a standard data. The data format is already defined by the EPC Global. So when the RFID reader tries to obtain the corresponding information, the EPC Global defines the frequency we can use. Frequency range from the 860 to the 960 MHz UHF frequency to communicate between the RFID reader to the RFID tag, and we need to know how to decode the signal. So we have the standard air protocol. So the RFID tag will provide its own unique ID number and maybe telemetry information to the RFID reader. Of course, the RFID reader can be produced by different hardware companies. So the IT engineer create the database or create a software application should receive the RFID reader information which obtained from the RFID tag. So there will be the standard software interface for the IT engineer or designer to receive the information from different RFID readers. There will be the same standard software interfaces and standard data, so we can deal with the data from different types of RFID reader. We have an application level event to filter the information. We have the EPCIS server to storage the information. Then we also provide the standard query language for the remote user, no matter the customer or the partner of the supply chain. They will give the standard query so we can reply the data or the information requested according to the standard query. Fortunately, today we already have the internet almost everywhere, so we just need to pass the data packet via standard network architecture. So we need an EPC Global Architecture Framework to define how to deal with the data, and we need to define the data flow from the tag to the computers or to the EPCIS. We need to define the data exchanging flow between the EPCIS and the remote user. That's why we need the EPC Global Architecture Framework. And in other words, if you are an IT engineer, you want to design the software or application fit the EPC Global network, you just need to make sure your software or application, even if you create an RFID reader or tag, you just need to make sure your product, no matter the software or hardware, satisfy the standard defined by the EPC Global. You can transmit or send or receive the standard data. Then your software or hardware can join can be the part of the EPC global architecture. EPC global standard support 3 broad activities within the EPC global architecture framework. Again, there are 3 broad activities for us to implement the RFID system. The first is identify individual product cases, lots, assets, so that they can be tracked individually. The first will be the identify. The second is try to capture the data about the movement of physical assets, creating visibility. So the second will be data capture. The third is exchanging the data with IT applications or department to turn visibility into information and action. So there were 3 purposes: identify, capture, exchange. And they also corresponding to some elements of the EPC global architecture framework. For example, tech data standard is defined for the identification purpose. The low-level reader protocol or reader management, even especially the application level event (ALE), will belongs to the capture purpose, data capture. The EPCIS belongs both purpose. Okay, EPCIS because it need to deal with the query from the remote user, so EPCIS it may need to obtain or capture some data real time. So EPCIS, only a few partitions of the EPCIS belongs to the capture purpose. Most of the EPCIS will belongs to the data exchange. And Object Name Service (ONS) is defined for data exchanging. Ever the framework, the architecture framework, about the elements and the purpose are given or a query in the certification exam. So you will need to know application level event elements corresponding to the capture. The tag data elements is corresponding to the identify purpose. The ONS is defined for exchange. Yeah, it ever given in the certification exam. The first element of the EPC Global Network Architecture Framework is tech data. It is a data standard for the identify. The EPC tech data specifications define the overall structure of the electronic product code (EPC). It also defines the EPC global coding schemes, most of these schemes being derived from the GS1 identifier. So finally, the specifications are also defined. The binary representations for use on RFID tag and URN stream for use within information systems. So we already described or we already learned about the RFID tag. The tag coding scheme, especially how to give the EPC manager number, how to give the object class number, how to define the serial number, we already learned. Now we just remind again. It is a fundamental principle of EPC global network architecture. We try to assign the unique ID number for the physical object or trade items. Then these trade items with the specific unique ID number can be tracked. Especially the unique ID identity is the electronic product code, EPC code, which has a capacity for over 274 billion serial number per item class on a 96-bit tag. So we can know to use the EPC code scheme, we can have a huge numbers for the trade item. If we give more bit for recording the numbers, then we assume that all the trade items or all objects over the world or the whole worldwide can be numbered, no matter a mobile phone, a house, a mouse, a laptop, a computer, a car, even a ship, an airplane can be numbered. So by using the company prefix or EPC manager number, we can know which company registers this number in the EPC organization. We can know the item reference, also object class numbers defined given by the company. Then by using the serial number, we can differentiate one from another. So we try to use numbers to represent an object. Even they are the same brand, the same type, we can still use the unique ID number to differentiate individual objects. In order to facilitate the use of the EPC global network by all industry sectors, the EPC Tech Data Specification provides a flexible framework that supports multiple coding schemes. This flexible framework enables each sector to incorporate its existing standards-based numbering system into its EPC codings. For example, the identity type SGTIN, the serial global trade item number, they will have different tag encoding scheme. 96 bits or 198 bits for the global trade item number, SGT number, and its corresponding related global standard 1 key will be GTIN, global trade item number, and the serial number will be added. So by the global trade item number and the serial number, the additional serial number, we can describe one trade item by the unique ID number. Of course, we can also use the electronic product code to represent the shipping pallet or cargo or other object by using the SSCC serial shipping carrier code. Also, we can use a global location number GLN with the additional serial number to more detailedly or more clearly to represent one location over the world. This identity type already described in the past courses, so we don't mention it. We don't need to spend too much time on it. So therefore, if we use the electronic product code, which represent the original trade item or object as the numbers, then in the information systems, an EPC electronic product code will be a uniform resource identifier or URI, uniform resource identifier, that is in text format. A URI identifier might specify the locations of a resource, such as a URL, or its name, a URN, uniform resource name, independent of location. So using a structured URN notation makes it easier to specify patterns. For example, for filtering IDs of the same product type or from the same manufacturer. The ID pattern are used in both the application level event ALE and EPCIS EPC Information Service specifications. So we can use the unique ID number to filter the requested information by the application level event and storage in the database by using the ID patterns as the index value. So the structured URNs are also used as a starting point for making an object service query. ONS, the object service, will be described and given in the future course. So we can use the EPC product code, including numbers or the text, to represent the original trade item or object in the information systems. So in other words, we can only need to query the numbers or search the specific numbers, then we can obtain the unique information corresponding to the unique ID numbers. We didn't need to do the search engine or the filter complexly. We only need to use the EPC as the index value to find the corresponding information, filter the corresponding information, and storage the information. However, even we already simplify the trade item information or object information as the numbers, we still need to transmit all the information in the radio wave type. And currently, the information transmitted from the RFID tag to the RFID reader will be the digitalized information represented by the 1-0 binary type. The tag data translation scheme and interface are provided by EPC Global for translating between the EPC encoding defined by the tag data specifications. So we still need to code or decode the original EPC electronic product code into binary coding. This ensures that the components of the end user infrastructure may automatically become aware of new EPC formats as they are defined. So you don't need to worry about the changing of the code scheme or translation schema, because you just need to receive the binary code from the radio wave. Then you only need to import or just need to send the binary code to the API for text data translation. Then, no matter you are original or traditional or in the past, many years ago, you have the data translation schema, and today there may be new version of the translation schema. You don't need to worry about that. You just need to include or import the translation schema. Then, by using the API of the text data translator, then you can still code or decode the electronic product code defined by the EPC Global. So it is an operation system independent system. You just need to follow the definition, follow the schema, then you can implement your own software or hardware to translate the EPC code to the binary code. So everyone can join this business or industry. You can implement your RFID reader or RFID tag, especially RFID reader if you want to create your own product. You just need to make sure you can receive the binary code and follow the translation schema, then obtain the EPC electronic product code, then your RFID reader can be used for any application. Here is an example, the representation of an electronic product code. For a global trade item 15 numbers, the header will be 8-bit. Okay, the number is already defined as a 0011 and 40 following. So filter value 3 bits and partition value will be 3 bits. Then we still need to add the EPC manager number, or we called company prefix here. There will be a 20 to 40 bits to code the original number in the GT number. For example, 0037, then 000 will be decoded as a binary code. Following will be the object class number. Here we call it item references. There will be a 24 to I think 4 bits or 40 bits. I will check it again. For the object class number, and the last will be a 38 bits for the serial number. So all the code will be represented as a binary code to be transmitted wirelessly as the radio wave. In other words, the IBID reader should transmit the original request or command as a binary code to the IBID tag, then obtain the binary code sent from the IBID tag, then translate it as the electronic product code. So one type binary code will be just similar to the physical type or signal type for the information transmission. And EPC code will be used as the data packet to be dealt with or to be managed by the IT application or software.